So this is the last section from this alternate chapter 8 on matrices and determinant, and this is section 8.5, determinants and Cramer's rule. No, we're not talking about Cosmo Cramer from Seinfeld. I don't know if you guys have watched Seinfeld, but that's one of my series that I will fall asleep to. It's just silly, and it got so bizarre that I watched it so much. I started experiencing a lot of that stuff in real life. Like just random stuff. I was like, wait a minute, I saw this on Seinfeld. Wait a minute, this is on Seinfeld. Another weird thing that I noticed with Seinfeld, the series Friends, they had like a lot of the same jokes, like same scenarios and situations. Like a lot of, I was like, was this written by the same people? Like, what is going on here? And I think Seinfeld came out before Friends. It was really weird. Anyway. All right, so with this, a few objectives here. We like to evaluate a second order determinant, solve a system of linear equations in two variables using Cramer's rule, evaluate a third order determinant, solve a system of linear equations in three variables using Cramer's rule, and evaluate higher order determinants. Okay, let's see what's going on. So the determinant of a 2x2 matrix. The determinant of this matrix is denoted by, the determinant is the vertical bars, right here. So this is a 2x2 square matrix. Notice these bars here. All right, it's just two vertical bars. That means the determinant of this matrix. And we define it by A1 times B2 minus A2 times B1. Right. We also say that the value of the second order determinant is this guy here. I'm just not going to say that. Right. So again, this notation, these vertical bars mean determinant. Okay. So evaluate the determinant of this matrix. So this came out when we were finding the inverse of the 2x2 matrix. We said the 1 over A times D minus B times C. That A times D minus B times C is the determinant, right? And we actually use it. I think we're going to see here, there is a technique to do that with the 3x3 matrix. We'll see it in a moment. Okay, so the determinant here is going to be 10 times 5, let's make that look like a 5. 10 times 5 minus 6 times 9. Okay. That's going to be a 50 minus 54, negative 4. There we go. Like that. Okay. All right. Okay, so we got negative 4 there. And you see it here. There's a little bit of a typo. I think that's supposed to be multiplication, but you get the gist of it. Okay. Evaluate the determinant of the following matrix. Let's do another one. Okay. So this determinant basically going to be 2 times negative 5. It is minus negative 3 times 4. That's going to be a negative 10. Double negative is positive 12. So it looks like it's a 22. Copy, paste. Okay. Let's see. 2, 4, negative 3, 5. 2, 4. Negative 10. 4 times 3 is 12. Oh, positive 2. I don't know why. I missed the sign. Boy, I am ready. I am already on weekend mode, right? So it's really just 2. Keep making these simple mistakes. But that's what happens when, like, you go fast, you rush, stuff like that. Yeah, 2 looks good. Wait a minute. See, now there's definitely a typo because something's not displaying properly. Okay, we just have to go with what we have. Because this is supposed to match and it doesn't. So there's something's off. We're going to just let that be for now. Okay, so Cramer's rule. Let me see. Okay, so given what a linear system of equations, then okay, so so if we wanted to get the solution right away. So if we wanted to solve this system, right? X is going to be equal to the determinant of, we got this guy augmented with B. So look, we take our coefficient matrix, right? A1, A2, B1, B2. Those kind of stay the same in either case. But then the numerator, When we're trying to solve for x, we replace that first column with the constant matrix. When we're trying to solve for y, we replace the second column with the constant matrix. Okay. And again, as long as the determinant is not 0. So what this does, with this technique, this takes us straight to the answer for x and y. That's really interesting, right? Using determinants, we can jump straight to the solution without other stuff, right? Let's see if we can get it. Let's get it. Let's see it in action. Use Cramer's rule to solve this system, okay? So I think when I've seen this before, they went on a write out each part separately, right? Let me think about it. So let me see. So we have our coefficient matrix, this 5, 3, 4, and -6. We're going to find that determinant, okay? We're going to call that, because I think the way it's called in later examples, we're going to call this capital D. And then this next part we're going to call D sub x, where we replace that first column with the solution matrix. So we got this 12, 24, and then the 4, -6 persists. We're going to find that determinant. Let me move this here just for some space. This here, and then let's find dy, where that's the 5, 3 persists, and now we have our 12, 24 over here. Okay, so let's find those different parts. So this first determinant, -30 minus 12 is a -42, right? Hopefully we did that proper. Okay. This guy, 60 plus 12 is a -72, minus 80 plus 16, 96. I think that's okay, 96. Ugh, these numbers. What is that? 168, -168. All right, we're just gonna go with it for now. That's what? 120. So 120 minus 36. Okay. That's a 40. It's a 64. That's a 40. No, 60 plus 20 is 80. 84, right? That's going to be 84. Okay. So then what we're saying is with these different components, x should be this -168 divided by, what is that, a -42? Is that a 4? X should be 4. And then y is going to be 84 divided by that -42, -2, -2, all right? So our claim is that the solution to the system is going to be 4, -2. Can I paste? Nice. Let's see the time. Okay, and we can check this, right? 20 minus 8 is indeed 12. 12 plus 12 is indeed 24. Mind blown, right? Another experience I had when I was in grad school, a lot of my professors were like Indian. So a lot of times Indian or just other cultures, or just basically everything except my complexion. And so it's like either I was always dealing with like heavy accents, or they just were. I couldn't tell if they were intentionally being clear to just throw me off because they don't want people like us to rise. But that's what it felt like. You know. So my ego kind of got in there. But again, that was just me and my ego. I think that if I just look for a good program where people are getting through, I can do it. But it was a lot of heavy accents or culture clashes. It was just a lot of weird stuff like that. Just anxiety. So that's why it's like, okay, I go out of my way to try to reduce anxiety because I know how that feels and it's not fun. And it's like, I know a lot of geniuses that get snuffed out just because of the game, right? Of the society. But if you actually like nurture people and encourage them, they'll like go above and beyond so much further. Like with the proper encouragement and nurturing, you never know what anybody, you know, can become. And I know I'm getting part of that from like Dragon Ball Z with like Goku, right? He was like, with enough training, anybody can survive. It's like dopey thing, but I think it's real. I think it's a real concept. You never know what the capability of somebody, right? So I try to encourage people. Okay, I'm gonna pause for a moment. So I have that it's officially 12:10. We have like 5 minutes left in class. I'm not gonna keep you all. So if you need to go, you're free to leave. I'm gonna go ahead and finish. We have what, like 23 more slides. We're moving. I'm gonna go ahead and finish this now. But again, if you need to go, you're free to go. Okay, but yeah, this actually worked. Okay, that was fun. So this was a 2x2. This was a linear system in two variables, right? So we used Cramer's rule. Yeah, they did it, right? So the negative 42, the d sub x was negative 68. That's like the numerator from Cramer's rule. Then dy, then we got these same results. Yay, and they actually worked. We tested them, they worked. So then now we want to see, okay, how do we find, so we saw how to find a determinant of a 2x2, but what if it was a 3x3? How would we find this? So notice, I'm going to show you a way to process all of this. Matter of fact, I think I'll do it here. Okay. So you see this long string of numbers. Let me show you how to do this. So then if we say A1, I'm just getting a copy right now, A3, B1, B2, B3, C1, C2, and C3. And then I'm going to augment a matrix like this. And then I'm going to put A1, A2, A3 again, and B1, B2, and B3. Okay? So, 2, 3. Okay. What's the best way? Let's go like this. That's decent, right? So that's A1, B2, C3, right? So we go 1. Let's just copy and paste. I guess I'll do this simple thing. 1, 2, and 3, right? And then let's paste and let's change that color. Let's go green. Okay. And then on the other way, we go here to here. Copy, paste. No, here. 3. Yeah, move it over. So there, there, there. All right. So these color patterns tell us what to multiply, right? So for instance, what we're saying is to find that number, the first blue streak is what? A1, B2, C3 plus B1, C2, A3, right? B1, C2, A3 plus C1, A2, B3, C1, A2, B3. And then when we go green, we say minus. So it's going to be minus A3, B2, C1, A3, B2, C1, minus B3, C2, A1, B3, C2, A1, and then minus C3, A2, B1. That long string, right? And you'll see they match up. Oh, nope. No, redo. This long string matches here. Matter of fact, let's do it like this. Let's just shrink it down. Let's try to match it as far as size. About like that. And then this. All right, they should all match up. Yep, 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 yep. All right. So I don't know, random, but it's interesting. But that's now. I know. I feel like I'm like, how did people like discover all of this, right? Like who was the first one to think of all of this stuff. Like, how do you discover all of this? But that's what mathematicians would do. Like in the past, like the thing that's so weird about today is we're inundated with like distractions. You know, it's clear that the system is set up so that we're constantly worrying about money, having to work all the time. We have no time to ourselves because they don't want us to rise. They don't, because the minute we have our basic needs met as far as food, housing, and like shelter and healthcare and stuff like that, and we start thinking, then the people in power will lose power, right? There's so many videos of people making like water powered engines, pulling water from thin air, drinking water from thin air, free energy with Nikola Tesla, like all sorts of stuff, right? So it's clear that the whole works system and honestly, education as a whole is really designed to kind of make people feel intimidated and feel lesser. And it wants to create this thing of a nation of employees instead of a nation of critical thinkers. But that's where my math is like, well, not my math, but mathematics is like a rebel, right? Because it encourages people for free thinking and critical thinking and like questioning and challenging. Don't just accept something because somebody says it, right? That's one of the things that I'm always gets on my nerves with like friends and family, right? Especially my mom. Like she just like watches the news. I'm like, yo, how are you still watching this? You don't understand that these people are like basically lying to you every day. Like, how do you continue to watch this? You don't challenge it. You don't question it. You're just going to accept it blindly. And then she does the same thing with religion. So I have to like woosah, and I have to go into this thing where I remind myself, like, okay, I know that ultimately, eons down the road, people are going to wake up. They'll realize how they've been duped, right? And it's just unfortunate because you kind of see things coming. But my thing is, I'll say something once, and then I let the people realize it on their own. Like I feel like I did my job at least saying it, and then let people, live their life, right? Okay. So the third order determinant, right? And so okay, so this whole long string, it basically comes from this guy here. So for instance, if you take that first column, when you do A1, right? When we focus on A1, right, we will block out this, and all that would be left was that 2 by 2. You see it multiplied. Now, I used to do it differently, but this is fine. So then when we do A2, right, we need to alternate the signs, so we do a minus. When we block out this, what's left is B1C1, B3C3, right? You see it here. Then when we do A3, we block out these, and then that's what's left, and you see it here, right? So that's where this long string came from. But I've seen it done with this cross pattern. I like the cross pattern. It's just that was easier for me. This is another way of doing the same thing, because then you have those 2 by 2 determinants, and you know how to do those. Okay, so you can kind of pick whichever one you like, right? You see it here. So then when we do A1, we cross this out, that remains. When we do A2, you put a negative, you cross these out, and then the blue remains, so on and so on. I'm going to kind of leave that be for now. So you can either use this technique or do the cross pattern like we did a moment ago. Either one works. Evaluate the determinant of the following matrix. Okay, I think I'm going to give this one a try. I want to try my cross pattern since the notes do it one way. So let me give myself, I need some paper. This is slide 16. Part is almost over. What a bummer. Let me copy slide 16 right here. Let's paste. Okay. So let me get a copy of this. Try that again. Copy, paste. Okay. Okay, so we're asked to find the determinant of this 3 by 3. Okay. So what I'm going to do, I like my little crosshair technique. So I'm going to say 2, 1, 7, -5, 6, and 0, -4, 3, and 1. Okay. And then I'm going to put my first two columns again. I'm going to do 2, -5, and -4, 1, 6, and 3. Okay. So then, okay, We did it like this last time. So if I do my crosshairs, a hashtag or whatever, copy and paste. So we're going to be multiplying these. And then if I paste, let's go style, let's change it to green. Starts in the lower left like that. Copy and paste. Okay. And paste. Okay, so that's what we're going to be multiplying. Oh. So then here, my blue. So if we focus on the blue, let me see. 6 times 2 is 12. So that's going to be a 12 plus, looks like that's a 0, plus, might have a negative. 15 times 7 is 70 plus 35 is a negative 105. Okay. Then we need to say minus for the greens. Hopefully we're doing this right. Minus. Now that first entry looks like it's negative. That's a negative 24. Wait, I put my negative. 24 times 7 is what? 140 plus 28 is 168. Okay, then minus, this is 0. And then minus, looks like it's a double negative, minus 5. Okay, let's crunch that number and cross our fingers, right? Let's see, what's going to be left over? It's a 7. So is that a negative 93? That's, we can just go ahead and do plus 168 and then plus 5. Let me see, that's a 7 and 68 is 75. So it looks like it's an 80. We got 80 when we did it. Okay. All right. So let's do this in our calculator to confirm before we look at the result. Right. I know there's a way to clear this. If I go to program, no. Matrix. Delete. Where is that? I forgot how to do that. I'm just going to reset my calculator for now, just for the interest of time. Okay. So let's go back to matrix, edit. So we have what, a 3 by 3? 3 by 3. Okay. 2, 1, 7. Negative 5, 6, 0. Okay. Negative 4, 3, and 1. Okay. I'm going to go back to the home screen, go back to matrix. I want to go math. I want to find a determinant of our matrix A. Nope. Matrix A. Okay. That determinant, we got 80. Let's cross our fingers. Woohoo! Right? Because when you get that wrong, you gotta you have to woosah. Because like, oh, I gotta go back and like either redo it or comb through it to try to find my error. And that whole thing of combing through and finding errors, that's like one of my colleagues. People would pay him top dollar to like go through their code and find the errors, like check a code for error. And so like that would involve basically suppressing most of the code, make sure a portion of it works, and then you pretty much go line by line. And then when something doesn't work, then you basically fix it, right? But it's this thing of slowing down, basically getting paid to do things that others either can't do or won't do, right? So he's increased his value in the marketplace. All right. If you want to increase anyway, forget all that. Okay, so we got 80, and then they're using the alternate technique, right? So I'm gonna leave that for you. Okay, and they got the 80 as well. Okay, we're almost there. Let's keep going. So Cramer's rule. So we have this linear system. We have the system of linear equations in 3 variables. So now, so this is Cramer's rule extended to 3 variables, right? We saw it with 2, all right? We're going to do the same thing in 3. This is the same thing. We're just going to extend it to 3 variables. Okay. I think this might be the last one. Okay. This is the same concept as before. You just, instead of a 2 by 2, you extend it for a 3 by 3. Again, these are all determinants. So, we need to be able to find determinants. I more than likely will just use my calculator. I'm not going to do all of those by hand. We did one by hand, so that was enough. So then use Cramer's rule to solve this system. All right, let's go. All right, let's do it. We got it. We got this. I'm excited. I don't know about you, but I'm excited, right? Okay. So first, let's find the denominator, right? For all the solutions or whatever. So that's going to be our D, which is just going to be the determinant of the 3 by 3 coefficient matrix, right? So that's going to be, we take our 3, it's going to be a -2, 1, 2, 3, -1. I'm getting flashbacks of when I was a youth, and I'd be eager to go outside during the middle of the week, go play basketball, skate, play with friends and stuff. And my dad would be like, "Well, you got to finish your homework first." And I'm like, "Oh," so I'm sitting there kind of antsy, like dancing in my seat because I want to go outside to play before it gets dark, and then I can't be outside. But I remember sitting there like for hours on end, going through this stuff, and then I would finish. I'll give it to my dad. He would check it. He'd be like, "Well, it's not right. You got something wrong." He was like, and then I'd be like, "Well, where?" He was like, "I'm not going to tell you. You got to find it." I'd be like, "What?" I was like, "No." So I had to like slow down and be meticulous to find my error, and then I would find it, and then I might have like 30 minutes left to play outside or whatever. But that's how I learned all this stuff. That little maneuver that he did that all the time. In hindsight, I'm thinking about it in hindsight now, and so that's what I'm experiencing right now because again, this is my weekend, so it's like I'm ready to take my pooch and go find a trail or something. But I do want to finish this. Okay, so now for the D sub x, right? We're gonna switch out that first column with the constant matrix, right? So that's 16, -9, and 2. 16, -9, and 2, okay? And then everything else stays the same. 4, 1, -1, and 3. We're gonna find that determinant. We want to find our dy determinant, okay? So then this column 3, 2, 1 stays the same. This one now becomes our 16. Nope. See, changing stuff. Don't be changing stuff. 16. I'm gonna have to find that error, right? Wasting time. And then this third column is a 1, -1, and 3. Okay. And then we do the same thing for z. I'm gonna leave some space for those results. And then we want to find our dz. That's gonna be 3, 2, 1, -2, 3, 4. And then this is now 16, -9, and 2. We need to find all 4 of these determinants. And then once we have these determinants, the answers are pretty simple, okay? So what I'm going to do, go to my matrix, and we're going to edit this first one. We're going to let this first one, we'll let it be D, right? So 3 by 3, okay? We got 3, -2. Hopefully we didn't, copy this incorrectly. You have to like slow down. -1, which is challenging in this age of distractions. 4 and 3, right? Okay, so that's our D. So then we want our dx. So we go back to matrix. We'll let dx be B, 3 by 3. Okay. Now wait a minute. Let me go to matrix. Is there a calculation that'll do this? It can do row reduce, row swap. Determinant. Okay, I'm not seeing it, so that's okay. All right. 3 by 3. So then we got our 16, -2, 1, -9, 3, -1. Okay, 2, 4, 3. Okay, we'll find that in just a moment. Let's go back to matrix and let's do C. We're going to let C be dy. That's a 3 by 3. That's a 3, 16, 1. Okay. 2, negative 9, negative 1. 1, 2, 3. 1, 2, 3. Okay. And one more. We want to edit D. Yeah, there we go. That's going to be a 3 by 3. So that's 3, negative 2, 16. Again, hopefully we're typing all this in properly. Negative 9. Because if one thing is off, it doesn't work. 1, 4, and 2. Okay. So now, with that, yeah, let me go ahead and let me calculate all those determinants. So then I'm just going to kind of go to the answer just in the interest of time. Okay. So then x is going to be dx over d. So that solution over this solution, we're going to get a result there. Y is going to be dy over d, and z is going to be dz over d. Right? I'm just going to use the calculator for all of that. Okay. Okay. So let's go back to matrix. Let's go to, we want the determinant. So we want number 1, we want the determinant of dx, which is our b, divided by, the determinant of a, which is d. Okay, so that should give us the result of x. That's promising. That it's a simple number. It's not always a simple number like that, but that's a good omen, right? So then the next one for y, we want to say the determinant of c over the determinant of a. So what I'm going to do is just copy and change b to c. So I'm going to go to matrix and replace b with c, and then just hit enter. Our claim is that y is negative 3. Notice I just wrote a code, right? So now we can quickly find the rest of them with those prompts. And then I'm just going to recall and change C to what? D? Matrix number 4. 4. Nice. Okay. And just to be complete, let me write these results out. Okay, I think this one over here is 232. Okay. Matrix. Let me go in order. Determinant of, what is that? A. Matrix. This one. That one was 58. That one is our B. That one was 116. And that one is C. Let's go like this. C is 3. We got a negative 174. Okay. Let me just highlight it. Come on, go. Okay, that's good enough. Right? So, for instance, for X, we did the 116 divided by 58. We got 2. For Y, we did the negative 174 divided by 58. We got negative 3. And for Z, we did 232 divided by 58, and we got 4, right? So our claim is that the solution to the system is the ordered triple 2, negative 3, and 4. So that's an X, Y, and Z. So then we can test those in the original to make sure that they work. Style. Okay. I'm just going to do it audibly. Let me see. 6 plus 6 is 12. Plus 4 is indeed 16. 4 minus 9 is negative 5. minus 4 is negative 9. That checks out. 2 minus 12 is negative 10. Negative 10 plus 12 is indeed 2, right? So this x, y, and z is a solution to the system. Okay, that was fun. So here's a type version of what we experienced. Set of the determinants. We got our d, our dx, dy, and dz. Oops. Evaluate the 4 determinants. We kind of did it out of order, but we got these results. Okay. And then x was dx over d, y is dy over d, and z is dz over d. So then 2, negative 3, 4. Oh, we got one more. Okay, let's see what else we got. So home stretch. If you're still hanging with us, you are a trooper, right? I salute you, right? The determinant of a matrix with n rows and n columns is said to be an nth order determinant. The value of an nth order determinant when n is greater than 2 can be found in terms of determinants of order n minus 1. The minor of the element aij is the determinant obtained by deleting the ith row in the jth column in the given array of numbers. The cofactor of the element aij is negative 1 to the power of I plus j times the minor of aij. Let me see this. So evaluate the determinant. So this explanation is basically using that technique that we had before, where you would like have an entry, you cross out that row and column, and then you multiply it by the determinant, by the remaining determinant. I think I'm just going to just piggyback off of the prepared notes, right? But what I'm mentioning is like, okay, so I think we kind of got lucky because this entry is a 0, but I'm thinking that it should be like this. We cross this out, so we would say 0 times that remaining determinant, and then we would say a negative. And it's going to be a double negative, but it's going to be, if we cross this out like this, so we would say 0 times that remainder determinant minus this times the remainder determinant. We kind of keep doing this thing, right? Right. I'm going to piggyback off my prepared notes. You see, okay, with 3 zeros in the third column, we will expand along the third column, right? Okay, so they simplified it. They chose a column that had a lot of zeros, so that cut out a lot of the work. When you try to expand along the 0, right? That's gone. So then to get the proper sign of this guy, you got to say -1. This is what? The second row, third column. So you got to say -1 to the power of 2 plus 3. So that's going to be a -5, and the resulting determinant comes from the 0, 4, -3, 1, -2, and 6, right? And then because there's zeros everywhere else, it's really just this process. This result's going to be a negative. That 5 is going to persist, and we know how to find this 3 by 3 determinant. So it drastically simplifies the amount of work. If we tried to expand along here, we were going to have a whole bunch of extra determinants we'd have to find. But because this column has a whole bunch of zeros, this is the ideal column to expand along, right? Okay. So if we wanted to find the determinant of this guy, we're going to expand along here. It ends up just being just this. And then we know how to find this 3 by 3 determinant. Okay, and you get this. We could also just do this in a calculator. But it is important to know how to do this stuff by hand. You never know, like, I mean, obviously you're not going to have to do this, but I'm just saying as a principle or as a general rule, like, it helps to know how to do something by hand and then also know how to use the technology. So I just encourage people to know how to do both, right? So that's not too bad. It's 40. It's like it's only 25 minutes extra. Again, you didn't have to stay, but well, we got one trooper, right? Okay. So with that brings us to the end of this method. Just do the best you can. I want to say with our assignments on My Open Math, we get unlimited attempts. The system is set to take your highest score. There's a minimal late penalty. Right? Yes.
Yeah. I don't have a question.
Yeah, you're good. So if there aren't any burning questions, we are going to end the session here. And from one beautiful mind to another, have a great weekend, ladies and gentlemen. Take care. Peace.
You too.